Hello dear students, today our problem is this particular figure. So we have basically a block whose mass is 4m. This block is lying on a table surface. Suppose the coefficient of friction between the block and the table surface is mu. There is a string, it's a massless inextensible string, and this string is passing over a single fixed pulley, as you can see, and a bob of mass small m is connected with it, which is oscillating in SHM. Okay. Now when it is oscillating, it is making some angle theta with the vertical. The angular amplitude is theta. So it is said that if theta equals to 60 degree and 4m remains at rest for this entire period of swing when theta is 60 degree, then find the value of mu. So this is the question. If theta is 60 degree and 4m remains at rest, then find the value of mu. So how we will progress with this problem? So first and the foremost thing, you see that when a pendulum oscillates, where in its whole trajectory is the velocity maximum. So if I consider that a pendulum is swinging from here to here, so the velocity is basically maximum here. So this is Vmax. If this is Vmax, suppose the tension here is, say I am calling it T0. Here also the tension in the string T0. Now if you go and sit on the bob is moving in a circular path. This dotted line is nothing but a circular trajectory. And what is the radius? Radius is the effective length. So you will experience an outward, radially outward centrifugal force. So m Vmax square by L. So you see, every single time when you go, where is the tension maximum? Let us understand very carefully. Suppose this is a part of the swing for any arbitrary angle theta. Theta is somewhere which is less than 60 degrees, suppose at any arbitrary instant. So here suppose you see the direction of velocity is this v, tangent to the path. What are the forces here? So mg, you get mg cos theta, and because of this v you will get centrifugal force, and at this position there is some tension T. So you see that in equilibrium, T is in equilibrium, we can write T is equals to mg cos theta plus m v square by L. Now where is theta maximum? So where is tension maximum? So T max implies theta equals to 0 degree, and theta is 0 degree where? At the mean position. So at the mean position what you will get? Say T max. Here also what you will get? T max. Okay, so this is the physics behind it. So therefore what we can say that T max during this whole oscillation is, here you also have mg plus m Vmax square by L. Okay, or this is mg plus m Vmax square by L. So this is the core idea of maximum tension. So whenever a simple pendulum swings, then what happens? Whenever a simple pendulum swings, it experiences maximum tension at the mean position. Okay. Now you see, if I consider this block of mass 4m, so this T max, when the bob is at the mean position, this T max is pulling 4m. Now let us see the forces which are acting on 4m. So this is our equation 1. So you consider the block of mass 4m. So its weight will act in the downward direction 4mg. The table surface will give it some normal reaction L. Suppose in this direction T max is acting. So this is the maximum force that can pull the block. For the block to remain just at rest, even when the maximum tension is acting on it, it must experience a limiting friction which is Tmax. And how much is that limiting friction? So for the 4m block, what you can say, that in equilibrium F limiting is equals to Tmax. What is F limiting? F limiting is mu times 4mg equals to mg plus m Vmax square by L. So this is the idea. So from here we got another equation. This is our equation 2. Now you see, whenever the pendulum bob swings from mean position to extreme position, then what are the forces acting on it and how we can progress with the problem. So I hope you have understood till here at first. Then I have to rub the board and proceed with the remaining part. So you see, when the pendulum bob swings from mean position to extreme position or mean position towards extreme position, theta is an arbitrary instant. It can be any angle between 0 to 60 degree. I have considered theta as an arbitrary, the angular amplitude at any arbitrary instant of time t. So please see, from here if you draw a dotted line, if effective length is L, so by this height it gets raised. So if this angle is L, if this length is L, so cos theta is base by hypotenuse. Okay, so if I give some names, P, Q, R. So what is PQ? PQ equals to L cos theta. And what is QR? L into 1 minus cos theta. So L minus L cos theta, that means L into 1 minus cos theta. Okay. So now you see, by energy conservation principle, what you can tell, that the gain in gravitational potential energy must be equal to loss of kinetic energy. Okay. So gain in gravitational potential energy must be equals to loss in kinetic energy of the bob. So basically the bob is rising from here to here. If you consider this condition, then the bob came down from here to here. So the center of mass lowered by L into 1 minus cos theta. Okay. So what we can say by energy conservation principle, half m Vmax square at the mean position equals to mgl 1 minus cos theta. And in the question it is given the value of theta is 60 degree. So as theta equals to 60 degree, so what we can say, Vmax square equals to 2gl 1 minus cos 60 is half, so that will give you half. So Vmax square equals to gl. So this is our equation 3. Now once you got this particular value, you put this value equation 3 in equation 2. So if you put 3 in 2, what do you get? Let's see. So put 3 in 2. So you'll get 4 mu mg equals to mg plus m Vmax square. Vmax square is gl. mgl by L. So mg. So from here I am getting 2 mg. So mu equals to 2 mg by 4 mg, and this is nothing but 0.5. So what is the value of coefficient of friction? Coefficient of friction between the block of mass 4m and the table surface is 0.5. This is the coefficient of friction. Once again I am telling you, it's a very simple concept, but it's a beautiful concept, that for the entire duration of swing of this simple pendulum, this block is not experiencing maximum tension. It experiences maximum tension when the bob is at its mean position, and Tmax is mg plus m Vmax square by L. Now this Tmax is pulling the block, 4m block. Okay, so even if the block stays at rest. That means its maximum value of friction, we are considering the critical condition. What can be the maximum value of, what should be the minimum value of coefficient of friction, right? So minimum value of coefficient of friction should be such that, so that the limiting friction exactly balances Tmax. Only then 4m will not move. And the maximum value of the force of friction is mu times 4mg. This is the maximum value of force of friction. Now when the bob is swinging during its journey, when it makes any arbitrary angular amplitude theta at any instant of time, then it loses, suppose it goes from mean position to extreme position. So it gains a vertical height of QR, that is L into 1 minus cos theta. Please see this, cos theta, this is 90 degree, cos theta is base by hypotenuse, so this much is L cos theta, this distance is L cos theta. So total length is L, so how much is QR? L into 1 minus cos theta, right? So the change in gravitational potential energy is equals to the change in kinetic energy, and that is evident from energy conservation principle. You are already given theta 60 degree, you put the values, and we used these three equations, and very easily we got the value of coefficient of friction 0.5. I hope this particular problem was useful to you. It cleared some fundamental concepts of friction and circular motion. Thank you very much.